So good morning. We are going to start with the talk. Welcome, everyone. We are really happy that you are here this early in the morning, the last day, when it seems everybody left yesterday for some reason. The talk is called Data Migration at Scale with RabbitMQ and Spring Integration. My name is Alvaro Videla, and he's Félix López. So Félix will do his intro later. I work on the RabbitMQ team in a role called developer advocate, that if any of you know what that means, I will be happy to learn. Because my role could be one day writing a plugin for RabbitMQ in Erlang. Last time I was improving a benchmarking tool that we have in Java and JavaScript that we plan to release soon. So the idea of this benchmarking tool that we have is or that we are going to release, is that you can specify in a JSON file, for example, how you want to run a benchmark against RabbitMQ, how many consumers, how many producers, what's the ingress and egress rate per second, many more things. You can specify all these scenarios in a JSON file, and the benchmark tool will just load that and run it for you. So that's an example of the things I'm doing on my daily job, let's say. So whatever developer advocate means. I wrote this book, or co-wrote it, RabbitMQ in Action. I created a simulator that I will show you later. This simulator is used at many companies today to teach people how to use Rabbit. So that's cool. If you're interested in Erlang, I'm writing about the internals of RabbitMQ in that blog. And that's my Twitter, my email, and GitHub. If you're wondering, I'm from Uruguay. If you've been watching the World Cup, don't worry and don't bite. I just eat already, so I'm fine. And I found that we have some things in common with Texas, Uruguay, Texas. We were both Spanish colonies at some time in history. And we also have 3 official flags. So whenever there's a national day in Uruguay, we go with 3 flags. Anyway, that's the book. And now, just to go into the talk, what is RabbitMQ? My part of the talk is to show you what RabbitMQ can do. And Félix will show you that I'm not lying, that they actually did it with their product. So RabbitMQ is a multi-protocol messaging server. It's open source under the Mozilla public license. It's polyglot. And is written in Erlang OTP. Why do you care that RabbitMQ is written in Erlang? I paid for a Spring conference, right? The point is that Erlang, and specifically OTP, has many design patterns, so to speak, and on fault tolerance, concurrency, and so on. So what this means is like the Erlang virtual machine plus OTP, this framework that comes with Erlang, means less code to be written by the RabbitMQ developers, and less code, less bugs. That's that. And it's a very hardened and battle-tested platform. So you can build a trustable product on top of that. When I was I worked 3 years in China, in Shanghai, and there is when I started using Rabbit, when I started writing the book, and so on. One of the reasons why we chose Rabbit was because it was written in Erlang, because we had a production CouchDB database aggregating logs from all the front-end servers. And that machine was like the worst machine we had because management didn't want to try Erlang. So they say, you put it there. If it works, cool. If it doesn't work, don't talk to me anymore. So that experience allowed us to that it was quite easy to bring Rabbit in play. Besides that, we actually had to use a queue, right? And by polyglot, it means that you can use Rabbit from many programming languages. And you can also extend Rabbit in programming languages that run on the Erlang virtual machine. For example, there is Elixir. Elixir is like a Ruby for the Erlang virtual machine. So if you want to extend Rabbit, you don't necessarily need to learn Erlang. And now, I don't know here, but it's quite cool to be an Elixir developer. So You will be a trendy hipster. Then 1 month after, you get the beard, glasses, and other stuff. So multi-protocol. RabbitMQ support at least these 3 protocols, AMQP, MQTT, and STOMP. AMQP stands for Advanced Messaging Queuing Protocol, and it's the base protocol that Rabbit comes with, or is actually implemented around that protocol. And MQTT and STOMP are implemented on top of Rabbit as plugins. So you can run Rabbit just as an AMQP server, or you can run it as AMQP and MQTT and so on. You can consume data, publish data as MQTT is a protocol made for devices with low energy and low resources. As far as I know, that's the protocol used by the Facebook chat on the iOS platform. I'm not saying they're using Rabbit, I'm saying they're using MQTT. And you can, for example, send messages in MQTT, consume an AMQP or whatever. MQTT stands for MQ something telemetry something. There is Google for that. It's a protocol that comes from IBM, and it's open and so on. And STOMP is a text-based protocol. It's very easy to parse, very easy to write a client, and it's one of the most used protocols inside the CERN in Switzerland. By the way, I live in Switzerland. I've been to the CERN, I talked with their developers, and they use everything that ends in MQ, basically is used at the CERN. ActiveMQ, RabbitMQ, Apollo, ZeroMQ, JMS, whatever. They use everything for some reason. And if you want to know which mustache is the one that you have to choose, that link there explains the difference between each protocol. And I mentioned that, that Rabbit is polyglot. So of course, there are clients for Java, Node, Erlang, PHP, Ruby, .NET, Haskell, and many more. Like if we have Java, of course, we have Clojure and Scala. The Java client is an officially supported client by RabbitMQ. So for example, if you buy support, you have support, as far as I understand, for what you have with Java. And new features that make arriving to the broker are implemented in that client. The same for the .NET client and the Erlang client. Those are officially maintained. And the Node.js client is written by a former RabbitMQ developer. I maintain the PHP client. Another RabbitMQ developer maintains the Ruby client. So that's that. And we even have that. I won't say that people still use COBOL, because when I presented at OSCON, a guy came to me after the talk to say, yeah, we use COBOL and we make a lot of money with COBOL. So I don't want anybody from here looking after me after the talk. So for people using COBOL, there's that. And this blog actually is from a developer from the cloud platform, I think, from Hewlett-Packard. So they are using Rabbit and whatever. And you can get it from there. It runs in many platforms. So if you can run the Erlang virtual machine, you can run Rabbit. And now I want to show you a demo with the simulator, basically explaining how RabbitMQ works. Oh, that's the goal. So in messaging, what we usually do is to try to send data from a producer to a consumer. To send data, usually what we need to have is an address, somewhere where we send the data. In RabbitMQ or in MQP, that's called the exchange. So what we do is to connect the producer to the exchange, and then we can send messages. But in this case, they just die there. They die at the exchange. This is the same as if you send a letter to the post office with the wrong address, like to Utopia, I don't know, and then it will be just dropped by the post office. But you can have queues, and you can bind the queue to the exchange and then the messages are routed to the queue. And of course, you can have more than one queue, so the data can be routed there. Let me, just a second, stay there. So now if I send messages, they go to both queues in a kind of fan-out style. So you might wonder, why do I need an exchange? Why can't I just send data straight to the queue? What's the point of that? And it's an abstraction similar, for example, when we go to an airport and we have the queue for poor people and the queue, like me, for example, and the queue, the business class. So you can have the binding key here on the queue. You can say, instead of just sending me any messages, send me business. And here we can say economy. One day I will travel in business, and then I will change this talk. Sorry. I'm not trying to be impolite. I'm just South American, so please understand. This is the normal joking down there. So if I send messages now, in case you don't see, what I did was changing the routing key to business and to economy. So what I can do now is send messages, but they still die at the exchange. Why? Because I need to specify in the message that I'm sending like business, for example. Then it will go there. And then if I want to send like a new economic customer comes, it will go there. But still the messages, as you can see here, they are just being queued. We need to have the consumer subscribe to the queue, and then it will start receiving messages. And the same for the business queue. Now, let's say we have a lot of clients. It's time to nearly board the plane, so we are all arriving there. You can see people keep queuing and queuing and queuing and so on. But the airline just opens a new counter, and we can see that Rabbit will start doing the round robin of the messages. And if there is more people, of course, we can have another counter, let's say, or consumer in this case, and so on. So to put another example, in Switzerland, when you go to the train station, you have like a computer that says, do you want international tickets or local tickets? So you click local, they will print a number, you will be in a queue. That queue will be for the people wanting local tickets, and then you will be called to your counter. The counter will be the consumer, the different queues according to what you want to buy, and the exchange is this computer that just sends you this way or that other way. Same thing happened in the Apple Store. You arrive there, somebody greets you, say you want to support, buy something, you want to buy something, go there, you want to support, go that way. So this abstraction actually is present in many areas in our life. And the idea is to abstract the publishing from the consuming. The idea is I'm producing this kind of data. I don't really care who is going to consume it. In this case, we can see we have business and economy. For example, we can say, for one message, I want to resize the image and log. So you can have one exchange for resizing the image, one queue, sorry, for resizing images, and another queue for sending the email. But the story doesn't end there. The exchange implements an algorithm, basically. And that's the type of the exchange. Whenever you create an exchange in RabbitMQ, you specify the type, which can be direct, fan out, and topic. And there are some more exchanges, but these are the basic ones. So because I'm using direct, it means it will check the routing key before routing. It will do something like select from queues where routing key the one sending the message, equals binding key, the one in the connection. RabbitMQ is not doing an SQL query internally because it's using a different database, but that's the idea. If we say that we have a fan-out exchange, you can see that the routing keys disappear because the fan-out exchange just doesn't care about routing keys. It grabs all the queues that are bound to the fan-out exchange, and it will send the messages there. So it's just like that. If you need to implement broadcast, PubSub, and so on, that's the fan-out exchange for. But the direct exchange is more like point-to-point messaging. This one is just send the data to everyone. So if you have a chat and you have a chat room, everybody logged into the chat room would have its own personal queue bound to a fan-out exchange, for example. And the third kind of exchange is called topic, where here the routing keys they are used again. Let me just restart so it's a bit clear. I have a topic exchange. So let's say I'm getting news, and I can say, or even a more realistic example, we have a server where we want to collect logs. And so whenever we send a log, we will, as a producer, we will have a payload, like something happened. And we will say, server 1, send this log from application 1, and it's info. You can see that I'm using words separated by dots. Of course, nothing happened because the binding key doesn't match. So I can say this queue is interested in stuff coming from server 1, from application 1, and that is info. I change that, and then the messages go there. This is a topic exchange. So far, it's the same as a direct exchange. But I can have a new queue. We cannot find the bug. We are seeing that we added this queue there, but server 1 is not telling us where the problem is. So let's say a client complained that he's seeing some, or they're seeing some errors on the website, but we want to debug it. We created a consumer. We just registered the queue into that server 1, app 1 info, and we are not seeing anything. So we can create a new queue, and in the binding key, for example, we say, OK, we have any server, application 1, info, for example. I change this, and maybe the error was originating in server 3. So it will go there, or in server 2. It will go to that one. So the star matches one word. The star is there to replace one word. But let's say we still don't see we cannot find the error, so we add another queue. And in the binding, we can say hash. So AMQP had hashtags before they were cool, let's say, and info. So I have that hashtag there. If I send a message now from application 2, it only goes to this one, because the hashtag matches 0 or more words. Star is only one word. The hashtag is as many words are there, as long as the message is an info, for example. But then maybe you want to also send errors. They are not going anywhere again. What binding will you do if you want to catch everything? Anyone? Exactly. So we have the hash. And that's the way to catch everything. So with a topic exchange, using hashtags will be the same as having a fan-out exchange. So to recap, we have the producer wants to send data, so it has to use an address. That's the exchange. If we don't have bound queues there, the message they go anywhere. And once we have the queues, we need to have consumers that subscribe to them. And Rabbit will do the round robin for us. So I will explain this a bit later, but for example, in AMQP, when you register a consumer, you can tell Rabbit, sorry, you can tell Rabbit, this consumer is in ACK mode, that is acknowledgement mode. This means the consumer will tell Rabbit, once it has processed the message, I did process the message. So then Rabbit forgets about that message. But if you are in no ACK mode, for Rabbit, as soon as it hands you the message, it just forget about it. So no ACK, of course, is faster, but it's more dangerous. The ACK mode, what will happen if your consumer crashes, the message will go back into the queue. So people usually ask, does Rabbit send duplicate messages? Usually, no. Rabbit doesn't send duplicate messages. But of course, if your consumer crashes and you were in ACK mode, that message will go back to the queue and will be delivered to somebody else. And I think Félix will talk about idempotency, right? So if you one of the best things to do in this kind of systems is to have idempotent consumers that if they get the same message twice, they know what to do. Maybe, for example, if you see this architecture or diagram, you can think that RabbitMQ is duplicating messages, that is duplicating storage, and so on. That's not the case. RabbitMQ only keeps track of one message, content, but it has an index where it tracks where the message is, which consumer has it, and so on. So when no consumer or no queue has a message, then the message is completely gone from the system, but the contents will be stored only once. Any questions so far? Yes? Can you please louder? I'm sorry, I can't. OK, the question is, if I have multiple processes that they need to receive the same messages, do I need to use multiple queues, right? The answer is yes. Queues are very lightweight in Rabbit. And yeah, each consumer will require to have its own queue if you want the same message going to everybody. For example, like in a chat application, let's say. If you want to send a message and then distribute it to everyone, each of those clients will need its own queue. In Rabbit, a queue is a Erlang process, and that's, I don't know, but really, really, really small. Like in an Erlang virtual machine, you can literally run millions of processes. In Erlang, the concurrency, I don't know, how many of you know Erlang? OK, everyone. This is for the people looking at the video later. By the way, before I continue, you want the book, please come to receive it. The first person asking a question gets the book. Can you? Please? Yes? You? Yeah? Please? Here you go. So that's the secret. Now you know it. If I'm giving a talk, I show you a book. It's because the first question gets a book. Now there are no more books. No.
Well, I'm seeing you've got 2 consumers.
Yes.
So at what point do you decide, should we have multiple queues or multiple?
Let me, so the question is, when do I need consumers, or how many consumers, how many queues, something like that. Let's say I have a chat app, and what I want is, if I send a message here, I want this consumer to get it and this consumer to get the message. That was your question, right? How you do that? You will get 2 queues, bound the consumer 1 to each queue. When you send the message arrives in both consumers. So yeah, we have one message. The message got kind of duplicated. It's not really duplicated. Went to each of the queues and each of the consumers. That was her question. Now, if you have, any of you know the book Enterprise Integration Patterns? Cool. So there is a pattern called competing consumers, where consumers compete for messages. Whenever you go to the supermarket, they are competing, the cashiers, maybe not willingly, but they are competing to attend you, basically. And that's, you can actually do that. You can, the message will go there, but then it will go to one of the others. So if for some reason this queue is backing up because consumers are not fast enough to process it, you can add more. And then only one message is going to each consumer in this particular queue. You see the difference? Yes, no? So if you want the same message going to many applications, then you will need 1 queue per application, basically. If you need to scale that up because the queue is backing up, then you need more consumers. Then, for example, I say, like, if there is no queue bound to the exchange, so in this case, I send the message in, it dies there. When you publish a message, I mean, in AMQP, there are way too many options. And what happens is, like, when you publish, you can say, I want this message to be persistent or not. I want this message to be mandatory. And if that's the case, then if the exchange doesn't have any binding or the message cannot be routed to any queue, the message is returned to the sender. So if you really need to know that, you can actually ask Rabbit to send it back. You can actually also send messages in what is called confirm mode. That means you send the message, and then asynchronously, RabbitMQ will confirm that it persisted the message to the hard disk. You can also enable replication in Rabbit. You can have many servers, cluster them together, then enable replication. And you can say, out of 5 servers, I want 3 of them to get the messages, to replicate the message. And when Rabbit persisted to disk the message in those 3 servers, it can send the confirmation back, for example. There are many ways to be sure that your message is getting where you want it to be, or getting back, or just discard it, and so on. Yes?
Message packages, what are some of the limitations of what you can send as a message package?
OK, so the question is what can be sent as part of the message package, payload, and so on. The only limitation, I think it has to do with the Erlang virtual machine or the Erlang distribution system, is 2 gigabytes of size. That's something imposed by Rabbit. It's not really in the protocol, I think. And the content, Rabbit doesn't care. It's just you can encode JSON, XML, send an image. Rabbit just really doesn't care. Rabbit is optimized for many small messages more than big ones. So if you want to move images around, it's not the best idea. The best idea will be to put your images in some storage, like on EC2 on Amazon somewhere, and then send a reference, like there I have this image that I want you to resize or whatever. So coming to that, I want to show you the next simulator, I think. Let me. So any other question from here? No? We have a blog post called Some Queuing Theory, Throughput, Latency, and Bandwidth. This blog post is really recommended if you want to learn about performance and how this affects Rabbit or what can Rabbit do for you in that regard. So we have RabbitMQ and we have a queue, right? And the queue, for example, is sending a message to a client. The client will do something and then act the message back. So there are many things that can change here. As a consumer, you can tell Rabbit that you have a QoS, like quality of service parameter, basic QoS is called, where you can tell Rabbit, as a consumer, I want to handle 50 messages at a time, or 1 message at a time, or whatever. So how do you decide that you want to handle 50, 20, 1,000, or 500? That's the prefetch buff, this prefetch buffer that you will tell Rabbit, I'm a new consumer. I want to have a prefetch buffer of 500 messages. So what Rabbit will do is start sending messages to that consumer until it reaches the 500th message. And when that is done, it will go to the next consumer in the queue. So it's kind of round robin what Rabbit is doing. It will go to the next consumer in the queue and then check what's the basic QoS, the quality of service setting of this other consumer, 300. So Rabbit will start sending as many messages as possible until it does these 300 messages, and so on. When the acknowledgement comes back, when a message consumer says, I process this message, and Rabbit receives the ACK, it says, OK, this consumer now has 499 messages. I can send again the 500th message. But you may have network latency in both directions. Your application may need some time to process the message. So why are you making those 499 messages to be sitting in your internal buffer? Why aren't you letting some other consumer process those messages? Or you, me, whoever, right? So there is an algorithm called Codel, which is described in that blog post, that lets you pick the right number. And the Java library actually, I think, implements this algorithm to pick the best thing for the basic QoS setting, because you will have some time to process each message. Then you need to send the ACK back in the network. So these 50 milliseconds are lost because Rabbit doesn't know that it can send you a new message, and you have 50 in another direction, you lose 100 milliseconds. So if you have a buffer to keep processing messages, it's good for you because that will make it faster. And in Rabbit, you can send a multiple ACK. You can tell ACK messages up to this ID, so you don't waste 1 ACK per message, let's say. And for that, I have a new simulator that we debugged yesterday. We enjoyed that so much. And I want to improve it later. But now the idea is that what I want to show you with this simulator, and that you will be able to use later, is that you will have 200 messages. This is a Premiere exclusive for the Spring. I want to have a queue, and this queue will have an ingress rate of 200 messages per second, right? Every second, 200 more messages. What's the goal of the simulator is that we can easily see how many consumers we need, what basic QoS settings we need, and so on, and understand how basic QoS works. So I add a queue, And you will see that here, the messages in the queue start growing. Now it has 1,000 messages. And at some point, Rabbit will run out of memory. I will come back to that. It doesn't really run out of memory, but you can see that this is accumulating memory. So I will add a consumer that it will take only 10 milliseconds to process a message, and it will tell Rabbit I will take 50 at a time. So now the consumer is always with 50 messages in its buffer, and is constantly consuming messages and knocking back to Rabbit. You can see that this keeps increasing because 10 milliseconds, 1,000 milliseconds per second, we get 100 messages processed per second. So if I add another consumer, now this should start to stabilize. But now we are even with the ingress rate. We have 200 messages coming in per second, 100 messages going out to the consumers. And this number will, you can see that it goes up and down, up and down, up and down, because we need another consumer. So if I add, let's say, some more consumers, at some point, this will start going down. You can see now. So you can, in your app, at some point, you will need to do something like that. Like your queue starts filling up with messages. You will need to say, OK, I need to have more consumers, drain the queue, take the consumers out. So I mentioned something about memory. Rabbit is not going to run out of memory. It has a mechanism which you can tell Rabbit what is the memory watermark. And if you reach that watermark as a percentage of your available memory, Rabbit will pause all the producers, and it will prioritize consumers so they drain the queues. If you're running out of disk space, Rabbit will do the same. It will pause the producers and then let the consumers drain the queue. So Rabbit has this mechanism to prevent that we run out of memory. Yeah?
So what does the RabbitMQ do with the app that comes to? What does it do?
So the question is what RabbitMQ is doing with the ACK coming back to the server, right? If you're in ACK mode, if you're in no ACK mode, Rabbit just doesn't care. But if you're in ACK mode, Rabbit knows that this message is being processed by a consumer, so it keeps it in memory. If your consumer crashes, Rabbit says, OK, this message back to the queue. If your consumer acts the message, it says, this message is not needed anymore, and it's discarded.
But after the act comes, the buffer will still crash.
Sorry? Yeah?
It's considered as consumed, right?
Yeah, exactly.
But if it is in the buffer, prefetch buffer,
you can, I mean,
why it crashes?
OK, so let's say, if I understand your question, the client has 50 messages in the buffer, and one is processing, and acts this message. So this message is not needed anymore, and then crashes. Those 50 messages in the buffer go back to the queue as well. OK? So the whole idea of this performance thingy is to prevent unbound buffers. And some realization I had reading a queuing theory book when I saw this equation, it's really simple. It says, if you have a mean arrival time that is greater than your service rate, so you are getting more messages than what you can process per second, what is going to happen? The queue length will go to infinity or grow to infinity over time. And this is a rather obvious result. But my realization is that queuing theory is mostly about having no queues. The whole point of queuing theory is that you optimize your system up to a point where your queues are basically empty or in a level where you can handle them. There is a blog post explaining how you can, all the techniques that Rabbit allows you to prevent unbound buffers. And I really recommend reading this book. I don't get any money if you buy it, but it's really interesting. It's queuing theory in action, basically. And it has all this equation theory behind how you can do scheduling, how you can improve scheduling in your app. And it has really real-life examples like how Google used queuing theory to improve their pages, for example. Then Rabbit, to sum up my talk, my part of the talk is what you get out of the box. You get persistent messages if you say so when you publish. You have publisher confirms, Rabbit telling you, I did receive your message. You have message acknowledgement. As a consumer, you tell Rabbit, I did process the message. We have mirror queues if you want to replicate data. We have message ordering. Rabbit delivers the message in the order they came, first in, first out. Of course, if a consumer crashes, you may lose order. There are dead letter exchanges. If a message cannot be processed, like a poison message, for example, you can reject it and dead letter the message to an exchange. You can put queues in that exchange, process the message later, or whatever. There are alternate exchange. If the message cannot be routed, you can say, if nothing can be routed in this exchange, send them to this an alternate exchange where I will check later what's going on with those messages. Message queue and TTL. If you don't want your queue to keep growing and growing and growing, you can tell Rabbit, I want this queue to expire with a TTL, or each message individually expire with certain TTL. Consumer priorities. Let's say you have machines that are not really the same, one more powerful than the other, so you want that consumers on this machine are prioritized over the others in the other machine, or they're more near to the server, so you have less latency, so you would prefer to send messages there and not in the other place, for example. Federation and shovel, this is a way to replicate across a wide area network, and this is what the New York Times uses to scale the whole setup. It's all orchestrated by via RabbitMQ. And now the new New York election poll WebSocket something live thingy from the New York Times, I learned this, all the WebSockets go to RabbitMQ. This was released this week. Anyway, federation, replication. Of course, we support SSL connections. We have user authentication with user and password. We have per resource authorization. That means you can say this user can only access these exchanges, not those one. It can only read but not write, so it can only consume but not send messages, and so on. There are different kinds of users, admin, and whatnot. There are many ways to authenticate a user. For example, using LDAP, all via plugins, and Rabbit exports an interface for each of the things that can be extended. So it's quite easy to actually write a plugin, provided you know Erlang. And we also have a management interface, which also has a REST API. This is a single-page application, let's say, that consumes that REST API, that if you are doing DevOps, you can actually connect directly to the API to list connections, list consumers, exchanges, queues, bindings, add user, remove users. All the stuff can be seen there. Before you ask me, we have tutorials. And if you want to see the actual code, I know you can all read and code. And it's really, really simple. This is what you need to, for example, receive messages. You will create a connection, connect to localhost. You will have a channel. It's a way to multiplex connections. And then, for example, you declare the queue. That's how you will do when I was dragging things around. Then you can receive messages from the queue and do something with the message. Of course, using a Spring Integration, you have this all on top there. Yes?
Does the queue itself have a REST API? For example, can you put a message in the
Yes. It's not optimized for that. I'm not saying it doesn't work, but the fastest way will be using the protocol. But it's possible with that REST API. Conclusion on my side is flexibility. If you ask me what's the difference between Rabbit and other queues, I don't like to get into that terrain. But one thing I know is that RabbitMQ offers flexibility. You have many protocols, many programming languages that you can use it. You have plugins for a lot of things, like you want a new exchange that do consistent hashing. You implement the algorithm, put it there as an exchange, and we actually have an exchange doing that. You want a new way of doing authentication, you just write a plugin for doing that kind of authentication, and so on. So questions, we had them already, and that's me, Félix. Thank you.
Hello, everyone. I'm Félix López, and I'm going to talk about data migration at a bit scale and the architecture that we developed to support it. And if there is something I would like you to learn from this talk, is that everything is easier when your architecture is designed using idempotent operations and allows you to control every single operation, no matter how small it is. Also, I'm going to show you our architecture is something alive, something that evolves through experience with real data. So you need the right tools that allow you to adapt it constantly. That's something that RabbitMQ and Spring Integration are for, okay? So, as I said, I'm Félix López. I've been working in the software industry for 13 years. I started working in web development, creating websites for large corporations, banks, and concurrency exchange. After that, I spent 4 years working in the mobile video games industry. Basically, that was far before Android and iPhone, where there were more than 1,000 devices, and it was normal to have between 50 and 30 versions of the same code. In those days, I created like 30 games, and after that, I spent a few years working with sensors and hardware, working in the Internet of Things. We built a sensor network to control and monitor the public lighting system in some cities in Spain. And now I'm working in data migration for satellite cloud. My main interests are programming in general, machine learning, big data, and I'm also the author of Mastering Python Regular Expressions. Okay? So, as I said, I'm working for satellite cloud. In satellite cloud, we do data migration in the cloud. This year, we've moved 3.5 million of accounts. That means 2 billion of contacts and 35 billion of emails. That is 1 petabyte so far this year of data, and we're supporting 60 providers. We have customers like Gmail, G+, Comcast, Time Warner, Harvard, Stanford, so on. Okay, so in this talk, first I'm going to describe what's our problem and what we're trying to achieve. Then I will describe how we solved it. And finally, I'm going to explain the biggest challenges that we faced while implementing the architecture. So let's see what's our problem. It's a little bit slow because I have too many animations. In satellite cloud, we provide a service to migration and data import to help email providers and social networks with user growth and engagement. We have some customers like Gmail and G+, that are integrated with us through our API. For other customers, we have portals so they can migrate new users into their systems. Our main use case is email and contacts, but it's not the only one. We have also domain migration or calendars or sites or whatever. We support a lot of services in the cloud. So as I said, satellite cloud does data migration. So what data migration means? It means diversity of sources, diversity of data, support high load, and to be fault tolerant. So we're going to see each of these in details. Our goal is to migrate any kind of content. So in order to do that, we have to think in an approach that allowed us to work in a generic way with any kind of content. That's why our platform works with hierarchical resources. So if a data can be described in terms of parents and children, it can be migrated for our platform. For example, contacts with groups, email with folders, file system at Dropbox, for example. You got the idea. Our platform works with a huge variety of data. That's normal because we're supporting 60 providers, but it also has to deal with diversity inside the same kind of data. For example, contacts and calendar both have kind of a standard, but very few providers follow it. So you have to be ready to deal with this diversity inside the data and normalize your data before working with it. Last year, we migrated 100,000 accounts. This year, we migrated so far 3.5 million, and our previsions are to migrate 2 million of accounts per month. So we need to be ready to scale our architecture as our needs are increasing constantly. As I said, we're supporting just for contacts and email 60 providers. So that means that we're exposed to the changes in their services. And with 60 providers, that means that we have a lot of changes. So we cannot afford to stop our platform every time we have to fix a problem in one provider. And also, we need to be resilient to any failure in third-party systems like MySQL or Redis. So that's how our problem looks like and what we're trying to do. Let's see in details how we solve it. Let's see first a global overview of our architecture, and then we can go into details in the key pieces of the architecture, okay? So this is, we're going to see the pieces that we have. First, the orchestrator is the core of our architecture, of our platform. It coordinates the migration process and is implemented with the Spring Integration using enterprise integration patterns. Then we have the, let me focus this, okay. We have the endpoints, okay. In this case, for the sake of clarity, we only have the contacts endpoint, but we actually have email endpoints, calendar endpoints, domain endpoints. These endpoints integrate external services through different mechanisms like APIs. So for example, Selenium in the case of the contact endpoints. And finally, one second, we have the API that we offer to our clients and is the entry point. So how does all these parts of the system communicate to each other? As we're going to see in details later, they do it with RabbitMQ. All the components in the system use RabbitMQ, and is key for our platform. This RabbitMQ allows us to be fault tolerant and to keep up with the current demand of the platform. Okay. Something important with the contact endpoint. Something important with the contact endpoint is that we can clearly see the problems that I mentioned before. The endpoint pulls the data from different sources. So they do that using different tools or mechanisms. Some providers have an API, and with others we have to use, for example, Selenium to scrape the content. Okay. Having different sources means that the data usually don't have the same format. So in other words, diversity inside the data. So how we solve the problem of diversity of data? The endpoints have to transform the contents into a common format. For example, contacts transform the data in vCards, and calendars transform the data in iCalendars. Okay? Also, as I mentioned before, contact endpoint is not the only endpoint that we have. We also have emails endpoint and calendar endpoints, which lead us to the problem of diversity of sources. So we design a protocol with the Spring Integration that all the endpoints have to fulfill. So these messages or format is something that has to be the same for all the endpoints. So let's see in details first the orchestrator and then RabbitMQ. That are the key points of our architecture. And in order to see how the orchestrator works, we're going to see the flows or process that a migration follows in our platform. Once a migration arrives to the platform, the orchestrator builds a migration plan for that migration. In order to do so, it needs to know the elements in the source account. So it asks these elements to the endpoint in batches. Basically, it's like a feed. For example, here we're asking 100 elements or contacts to the group root. Okay? And then the endpoint has to reply with the ID for each element and with what's the next element for the following batch. As you can see here, this is the protocol that I mentioned before. All the endpoints has to do the same, to support the same operation and to respond with to reply with the same thing. Okay. Here we're only asking the ID and the parent because we're creating the migration for the plan for the migration. We're not doing the migration yet. Once we have the elements, the ID is stored in the resource tracker, and we store in Redis temporary data or intermediate data like the next element. Once the batch is complete, we can continue with the following batch. Okay? Once the describe operation is done, the orchestrator has a completed plan for the migration, so it can start moving elements. The first thing, the orchestrator asks the resource tracker what elements can be migrated. This operation has into account dependencies among elements, so it will move first the elements that don't depend on others. For example, in the case of contacts, if a contact is in 2 groups, it will move first the 2 groups and then the contact. Once we have that elements, we set a counter in Redis in order to know how many elements are still pending to be migrated. So it won't run another batch in this migration until the current batch is already completed. Okay? Also, in this way, we avoid to query MySQL to know if the batch is completed or not every time a resource is migrated. After that, it asks the source endpoint the elements. And the endpoint replies with the content of the element in a field called generic. So as you can see here is bigger because we're migrating contacts, but if we were migrating calendars, in this field we will have iCalendar, for example. Once the elements arrive to the orchestrator, the elements are sent directly to the destination endpoint. Note that we're not storing the content of the elements. Okay? Then, when the destination endpoint has inserted all the elements, it replies with a new ID for those elements, and then the ID is stored in the resource tracker, and the counter in Redis is decremented. So once the counter in Redis is 0, we can continue with the following batch. Okay. So this is how the orchestrator works. This is the core of our platform. Is the one who coordinates all the migration. Okay. And now we're going to see another key PC for us that is RabbitMQ. It's our message-oriented middleware. As I said in the global overview of our architecture, every component in our platform use RabbitMQ to communicate with each other. As Alvaro said, it has support for quite a few languages, and you forgot Python. We have support for, we have endpoints for Python, Ruby, and Java. And this is something really important for us because we are integrating a lot of services. So we need to choose the language that best fit our problem. So sometimes we need to use Java, sometimes we need to use Python, or maybe Erlang, or maybe I don't know, Haskell. Depends on the provider, and depends on the problem that we want to solve. It's pretty straightforward to scale endpoints on demand. So we can spin up instances and start consuming messages right away. In this way, RabbitMQ allows us, help us with the problem with high load and fault tolerant, because we can replicate every component in our system, and in that way we can as I said, we can keep up with the demand, or we can be resilient to failures. And also, it allows us to apply logic inside itself. Routing, Alvaro has explained that, but it also allows us to listen to an edge chain and analyze the traffic that is happening in that edge chain without affecting other parts of the architecture. Okay. So we've seen how our problem looks like, how we solved it, and now we're going to see the biggest challenge that we face it while implementing it. Basically, it's like how our architecture has evolved during the time. The first challenge is hard load. The describe operation in our platform is the most expensive operation, and also the most important operation in the platform. And at the beginning of the project, the endpoints didn't have any limit to describe an operation. That means that they could send as many messages as they wanted. That obviously was potentially harmful, as one endpoint could flood the platform, the orchestrator, Redis, and MySQL with a lot of messages. For example, in this case that we want to see, this endpoint has sent us 1 million of messages as fast as it could. So this could have a catastrophic impact on all our components. Okay. Also, as we didn't control the describe operation, we didn't know the current demand of the platform. For us, it was impossible to know the number of messages that were currently in the platform, and even it was impossible for us to stop it, to stop one operation in favor of others, for example. Yeah. Can you repeat it?
The element
yeah.
Is that attribute some kind of a bean? Is that how you can relate?
Well, his question is that is the element is an attribute in a bean? Yeah. No, well, I don't know if you know how with the Spring Integration how it works, but I didn't even have beans in my. I mean, there are beans, but for me it's configuration. This is it's an XML. Basically, the message that you see here are XMLs. Okay, so it's an attribute in an element or an element inside the XML element.
So you were mentioning as if each attribute had its own migration.
No. You're asking that if each attribute has its own migration. No, it's not. The migration is the whole process for one account. But each element in the source account has to do the same process. First, we have to describe it. So basically the endpoint has to say to the platform, hey, I have this element with this ID, and his parent is this folder, for example. Okay? And then once the describe is completed, the orchestrator is going to say, I have 100 elements that don't depend on anyone, so I can send it to destination. Okay? And then what it does, it asks the source account, give me the real content of these elements, and then it sends those contents to destination. Okay? But the contents are inside an XML. Okay?
The message that is actually going to the orchestrator is an XML.
Exactly. No, exactly. Okay. So I was talking about the challenges that I was mentioning that for us was a problem that we didn't control we didn't have any control. So the describe operation. The solution that we've seen was to transform the describe operation in a feed. So now we ask the endpoints to the elements in batches. So we can control how many elements we want. We can control how many elements are pending to be migrated, how many elements are currently being migrated, and we can control stop or pause or resume an operation. Okay, so we can stop an operation in favor of others, for example. We've seen this before. Basically, it's the describe operation. Okay. So before having as a recap for this challenge, before the describe operation as a feed, we have potentially harmful describe operation, as one endpoint could do could send as many messages as they wanted. We didn't control the traffic of the platform, and we didn't have any control about the operations, so we couldn't stop an operation, for example. And after we have controlled operation, we can resume an operation, stop it in favor of others, or maybe the platform is quite busy because there are a lot of migrations going on, and we don't have resources to spin up new machines. We can stop the migrations that we want. But in fact, it's the orchestrator who is going to do it automatically. The most important thing is that now we have a predictable behavior. So we know what is going to happen in the following seconds. We know how many elements can be migrated and how many elements are still pending to be migrated. Okay. So let's see the second challenge that is also related to high load, but in this case related to the stores and to the speed in the platform. This is the aspect that we our platform had before at the beginning of the project. As you can see, there is no Redis in the equation right now. That means that when we were doing a describe operation, we have to query MySQL every time. Okay, every time a resource was migrated, we have to query MySQL in order to know if the batch was completed or not. What this means is that we were querying MySQL as many times as we were doing inserts. So this obviously was a bottleneck for us, and it's really difficult to scale because as your demand is increasing, you have to scale more and more and more. Okay? So the solution for this, as we've seen, was to add Redis. So now Redis is our intermediary data. We set counters in Redis to know how many elements are still pending to be migrated. So we only have to query MySQL once per batch. Imagine that we have a batch with 1,000 elements. Before, we have to query MySQL 1,000 times, and now we have to query one time. So we don't depend on the size of the batch or on the size of the account. Okay? This is what we've seen before, okay? That now we have only to query MySQL once. The only thing we're doing is inserting elements, and after the batch has completed, we query MySQL. And as a recap of the challenge, before we had high load queries on Redis, and now we have far less MySQL queries, obviously. Something that I didn't mention before, that before Redis, we have in-memory clean check. Clean check is an enterprise integration pattern that allows you to store information and recover it later. It was in memory, so this was limiting us to scale our platform horizontally, basically the orchestrator. Okay? After adding Redis, we have distributed clean check. The good thing about the Spring Integration is that to add Redis in our architecture is as simple as this. Okay? So we have distributed clean check only with this configuration. Okay? So it's really, really easy. The last challenge, and maybe the most important for our architecture, is related to fault tolerance. This is a flow in Spring Integration. After adding Redis, another problem arose for us, is that we had flows with as many third-party system operations as third-party system we have. I mean, for example, in this operation, in this flow, we have Redis and MySQL in the same flow. So what would have happened if there had been an error in MySQL and the message was requeued? The counter in Redis would have been decremented twice. So you can see the problem. That means that the next batch would have started before it should. So that could lead to that the predictable behavior that we had, it's impossible to have it because we will have inconsistent data and several migrations at the same times that the orchestrator didn't want to have. Okay, so the solution for this is to split your flows with as many flows as third-party operations you have. For example, in this case, we have to split the flow in 2 operations, one for Redis and one for MySQL. Okay? So let's see, this is how it looks right now. We have one flow for Redis and one flow for MySQL. Okay? Let me go back. Imagine that we're migrating 100 elements, and the destination has inserted those elements. Then destination send the confirmation message with the new ID. This message, each of these messages arrive here. Then the message is transferred to work with it. Here we start information from it. Here we decremented the country in Redis. Now we store the new ID in MySQL, and then if the batch is completed, we send the message to a queue who is going to process the following batch, okay? But with this solution, every message first arrives here. Then we do the same thing, transfer the message, get some information for it, and decremented the country in Redis. And now we send the message to a new queue. And the flow, the MySQL flow, it's listening to that new queue, and then it does the same thing, transfer the message, get some information from it, and then store the new ID in MySQL. And it checks if the batch is completed, and then it sends the message for start a new batch. So if there is a problem in MySQL, we can repeat the flow without side effects. So that allows us to stop. We can even stop MySQL and start it again 1 hour later, and everything is going to work, because we can repeat the operation without any problems. And with Redis, it's the same thing. Okay? So before having the idempotent operations, we have flows with side effects. The operations weren't repeatable. We weren't resilient to failures in third-party systems. Now, as I said, we have repeatable operation, so we can repeat any operation we want in the platform without any problem. And with resilience to parties in third parties. As I said, we can even stop MySQL or Redis, and everything is going to work when we resume the service. The only drawbacks with this is that now it's difficult to maintain, more difficult to maintain, because you have many more flows. But it's a trade-off. Now I sleep better, because I know that this is more resilient than the other option. And as a conclusion, as I said at the beginning of the talk, for me, what you need to learn from this talk, or at least what I learned from this experience, is that the architecture is something that is not static, and it's not something that is for all your life. It's something that is going to change for sure. So you need to choose the right tools that allow you to adapt it as you learn with experience. So, questions?
So you had a contact endpoint. So what is the role of the contact?
Okay, he's asking what's the role of the contact endpoint. The role of the contact endpoint is to integrate different services, contact services, and then transfer all the data that came from that contact services into the same format. So imagine that, for example, the contact endpoints work with Gmail, but also work with, I don't know, the email of Alvaro Videla, that maybe he has an email provider in his house. And Gmail has an API, but his email provider doesn't have an email provider. So we need Selenium to scrape contents from his server. So what the contact endpoint does is to try different strategies to get the information from those services. The Gmail endpoint is going to get the data in the format that Gmail wants, but we need to transfer the data in bcar. And the data from his server is going also to be transferred in the same format, in bcar, okay? Also, his responsibility is to fulfill the protocol that the orchestrator has. So it has to respond to the describe operation, it also has to respond to the get operation, and also has to do the put operation, okay? Basically, it has 3 operations, and it only understands vcars. So you cannot send a contact in LED, for example. It's only vcar, okay? That's with email is the same thing, and with calendar is the same thing. They have to fulfill a protocol with the orchestrator, and they have to transfer the data into a common format for all the providers of the same kind, okay?
You used queries for MySQL, you added Redis. At that point, was it a decision based on it being non-relational, some sort of document storage, or
no?
The reason for Redis, not just another MySQL?
Yeah, the decision for Redis is because Redis it allows you to have counters and atomic operations that are really, really fast. It's designed for doing this kind of operation that you have. For example, in our case, we have a set of IDs. So you only have to say remove this string for this set, and it's really, really fast, more than MySQL for this kind of operations. So, okay.
So you mentioned MySQL can go down for an hour and come back and still be in the same state as Redis once it processes the message. What kind of thought do you put into the design? You know, a lot of times the database uses something simple like have the database stamp the date updated, date created. You might do something more complicated like have database triggers with logic. So, you know, given that architecture, how do you usually put that thought into, I guess, dumbing down the database?
If I understand good, what you're asking is that what happens if the database have more complex logic like triggers and things like that? Yeah, that's different. In our case, the resource tracker is only in order to store elements. So we only store. It's basically we have there the plan for the migration. So we have the elements that we have to migrate, the IDs for those elements, and the new IDs in destination. So it's basically that. If we have to do something complex, it's going to be done for the orchestrator. Okay, so we don't have. Also, we don't like something like triggers or things like that because, as I said, something that we learn is that we need to change things along the way. So if we have triggers, it's difficult to change the data store. So, yep. Can you speak louder? The good thing is that we don't have to do that. She's asking me, sorry, how can we be sure that the data is consistent between Redis and, yeah. The good thing is that we don't have to do that because in MySQL, we have the IDs we have a job key that is the relation between the Redis and MySQL. So the only thing that Redis has is the number of elements that are still pending to be migrated, okay? So the way it works, the platform is that until all the elements in Redis have been removed, we're not going to add new things to MySQL. So they're always I mean, they don't need to be synchronized, okay? I don't know if I solved your question. Can you speak another, please?
If in your situation, you have the situation that you have to sync things, which I think the answer is no, but.
No, no.
Yeah.
Any more questions? Okay, thank you. Thank you for coming.
Thank you.